Chapter 11, Part 1. Male Chauvinism. Humanity often prides itself on having emancipated half its population, the half we rather grandly call women. The disgraceful era when women were treated as inferior beings, property, or mere objects of desire is, we like to believe, behind us. Yet, according to evolutionists, the latter point remains stubbornly relevant. After all, where else would illegitimate children come from if we insist on viewing evolutionary progress solely through the brain's pursuit of the greatest good? Let us not forget that humanity nearly brought itself to the brink of extinction during the Renaissance, simply by prioritizing gallantry and the cultivation of personal qualities over good old-fashioned physical attributes. We can leave such indignations to future generations, those who will fully comprehend the primitiveness of our current pedagogical methods, and instead turn to the topic of terminological inequality. Why, in this era of gender equality, do we still acknowledge differences between men and women, rather than eliminate all reference to them? The answer lies in medicine. It's widely known that the same medication might require different dosages for men and women due to factors like body composition and metabolism. Of course, I say this in jest. The real differences go far beyond medicine, necessitating distinct approaches in many areas of life. Take physical labor, for example. We could try fostering a societal narrative that women are just as physically strong as men, encouraging them to take on the most demanding jobs requiring intensive exertion. We could increase wages in these fields, plaster banners featuring cheerful women wielding pickaxes or carrying cement bags, and instill a love for such professions in girls from nursery school onward. However, such an approach would defy common sense. Why impose an artificial form of equality on women, one that damages their health and is economically unviable? Interestingly, even without deliberate narratives to reinforce it, one can observe situations where women are exploited by their partners. Personally, I experienced a form of culture shock upon arriving in an English-speaking country where I frequently noticed women carrying the heaviest burdens, grocery bags, purchased goods, and even children, while their male companions walked alongside, often embracing them or leaning slightly on their shoulders. At first, I assumed these instances were isolated or rare. However, years of observation in various settings revealed this as a consistent trend among those under 35 years old. The relentless promotion of absolute equality seems to have convinced the younger generation to disregard the biological differences between the weaker and stronger sexes, a phrase not meant to demean women, as one young man accused me when I questioned his habit of letting his girlfriend carry everything. Proudly gesturing at her skinny arm, he called it her bicep, suggesting she was perfectly capable of handling the load. In reality, this aphorism reflects biological differences, not inferiority. Rather, it highlights the natural principle of distributing tasks according to abilities and efficiency. Before delving further, I will briefly outline a series of established facts about how male and female organisms differ. I understand that this might seem banal to you, but I ask for your patience. The intentional avoidance of discussing these differences has rendered them non-obvious to many, despite the reality that certain tasks are naturally easier for some individuals than others. 1. Different sets of chromosomes. Men and women differ fundamentally in their chromosomal makeup. Men possess an unequal pair of sex chromosomes, a large X chromosome paired with a significantly smaller Y chromosome. In contrast, women have two X chromosomes. This symmetry provides a backup copy of genetic material, helping to correct errors and lower the frequency of mutations. As a result, conditions such as autism, schizophrenia, and many other genetic disorders are less common in women. Biologically speaking, men can be considered mutants due to the presence of the Y chromosome paired with a single X chromosome. The absence of a second X chromosome eliminates the genetic redundancy required to mitigate disruptions, contributing to higher susceptibility to genetic disorders. This imbalance also partly explains the challenges many women face in finding a suitable partner, despite the fact that male conceptions outnumber female conceptions. A significant proportion of male embryos fail to reach birth due to higher rates of implantation failure, miscarriages, and early childhood mortality. Moreover, the paired X chromosomes in women contribute to a phenomenon known as accelerated maturation, which explains why girls on average develop faster in various aspects, including the maturation of brain centers. The Y chromosome, however, influences the development and functioning of the brain's dopaminergic system. Research indicates that men, on average, exhibit higher activity in this system than women. This difference may partially account for gender-specific behaviors and vulnerabilities to certain disorders. For instance, increased activity in the dopaminergic system is linked to a higher prevalence of alcoholism and drug addiction among men. It may also explain men's greater inclination towards seeking new sensations and engaging in riskier behaviors. Furthermore, dopamine neurons play a critical role in the development and control of motor skills. Interestingly, Parkinson's disease, a condition characterized by the degeneration of dopaminergic neurons, shows a marked gender disparity, with men being about twice as likely to develop the disease as women. 2. Hormonal differences. During intrauterine development, the formation of male sexual organs triggers the production of significant amounts of testosterone. This hormone, coursing through the bloodstream of the developing fetus, sets the stage for changes that will, quite dramatically, shape their entire future life, particularly by influencing cellular functions and molding the brain and nervous system. Interestingly, research suggests a link between higher prenatal testosterone levels and language development. The higher the testosterone levels, the smaller a child's vocabulary tends to be at the age of 2. This might explain why girls typically begin speaking earlier than boys. However, hormonal influences are complex, and hormone levels can vary independently of a child's biological sex due to a multitude of factors. Testosterone's impact is extensive, influencing vital processes such as oxygen exchange, metabolism, energy regulation, and overall body structure. Many of the differences between sexes described in this chapter are primarily underpinned by two factors: chromosomal composition and the influence of sex hormones during fetal development and sexual maturation. 3. Immune system. Some diseases affect men more than women, and vice versa. Until recently, this phenomenon was poorly understood. However, researchers from the University of Melbourne have taken a step closer to uncovering its causes, as reported by Science Daily. The key differences between male and female immune systems lie in the strength and efficiency of their protective mechanisms. Women tend to have stronger immune responses, offering better protection against infections compared to men. This evolutionary advantage is logical. Women's primary biological role, carrying a fetus, giving birth, and nurturing the child over an extended period, demands robust immunity to safeguard these vital processes. From an evolutionary perspective, the reproductive role of men is comparatively simple: the transfer of genetic material. Once this task is fulfilled, nature appears to lose interest in them. In essence, a man's primary biological function is considered complete after procreation, though exceptions do exist. In some species, males have evolved to protect their offspring, allowing females to reallocate energy-intensive biological mechanisms toward the development of unique and specialized traits. Below, we will explore these features in more detail using the example of the development of the prefrontal lobe area. Interestingly, the immune system's cellular components, for example lymphocytes, macrophages, plasmacytes, and humoral agents such as antibodies, cytokines, do not inherently differ by sex. However, immunity is intricately linked to the nervous and endocrine systems, where sexual differences abound. Over 1,100 genes have been identified that contribute to variations in immune responses between men and women. These genetic differences underscore the profound interplay between sex-specific biology and immune system function. Estrogen receptors have been identified in various immune cells, including B and T lymphocytes, dendritic cells, and natural killer NK cells. Women generally produce higher levels of antibodies through B cells, and estrogens play a significant role in enhancing innate immune responses. These hormones stimulate the production of adhesion molecules, which allow lymphocytes to localize at sites of damage, as well as chemokines, substances that regulate local immune reactions such as inflammation. A more efficient immune system in women is often linked to elevated levels of cytokines and other immune mediators, leading to a heightened response to infections and injuries. Research also suggests that women exhibit faster bone healing after fractures, attributed to a more active regenerative capacity in their bone tissue. Pregnancy represents a period of heightened immune protection for the female body. Elevated levels of female sex hormones during this time safeguard both the mother and the developing fetus. Through the umbilical cord, maternal antibodies and immune cells are transferred to the fetus, providing a foundational layer of immune defense. This maternal protection continues postpartum, as antibodies are further delivered through breast milk, offering extended immunity to the newborn. With age, the immune system undergoes changes, and these changes manifest differently in men and women. Women tend to sustain higher immune activity into older age, which is associated with increased longevity and a reduced risk of numerous diseases. However, this robust immune activity may also contribute to a higher prevalence of autoimmune diseases in women, where the immune system mistakenly attacks the body's own tissues. These differences are believed to stem from hormonal influences, particularly the prolonged effects of estrogen. 4. Circulatory system. The normal erythrocyte count in women is approximately 3.8 to 5.2 times 10 to the power of 12 cells per liter, compared to 4.3 to 5.7 times 10 to the power of 12 cells per liter in men. Women, on average, have 8-10 milliliters less blood volume per kilogram of body weight than men, and their hemoglobin concentration is typically 10–15% lower. Normal hemoglobin values range from 120–160 grams per liter for women and 130–170 grams per liter for men. Furthermore, the erythrocyte sedimentation rate, ESR, is usually higher in women, with norms of 2 15 millimeters per hour compared to 1 10 millimeters per hour for men. These differences translate into a lower oxygen-carrying capacity in women. For instance, while men require 6 liters of blood to transport 1 liter of oxygen, women need 7 liters. Additionally, the female body contains less total water due to a higher proportion of adipose tissue. On average, women have 50–55% body water, compared to 60–65% of men. This makes women more prone to dehydration, where even minor fluid deficits can quickly lead to organ dysfunction, compromised cardiovascular performance, reduced immune activity, and increased sensitivity to stress. Despite these differences, the female circulatory system has unique advantages. Women have more elastic blood vessels influenced by estrogen, which provides greater adaptability to changes in blood pressure and flow. Moreover, women tolerate gradual blood loss far better than men. While losing a liter of blood might send a man straight to intensive care, a woman might simply wonder if she needs another coffee, thanks to their monthly endurance training. Women's hearts are smaller in size and myocardial mass compared to men's, with narrower vessels and thinner walls. They contract more frequently but eject less blood per beat into the circulatory system. Women also tend to have a faster resting pulse and exhibit distinct differences in blood pressure regulation. Functionally, the female cardiovascular system may match the male in endurance-related activities, but is generally less equipped for strength-oriented tasks. The endocrine system significantly influences the function of the heart and blood vessels. Estrogens, which are abundant in the female body, have a protective effect on the cardiovascular system. They improve vascular elasticity and support heart muscle health, reducing the risk of thrombotic complications. As a result, premenopausal women enjoy a lower risk of cardiovascular pathologies compared to men. However, after menopause, the decline in hormonal protection leads to an increased prevalence of heart and vascular diseases among women. Women are more sensitive to certain risk factors, particularly tobacco smoke. Prolonged smoking poses a greater danger to women than to men. For example, smoking just 1 cigarette a day increases the likelihood of ischemic heart disease by 48% in men and by 59% in women. Similarly, the risk of stroke rises by 25% in men and 31% in women. Cardiovascular diseases also manifest differently in women compared to men. Men often exhibit classic symptoms of heart disease, making diagnosis more straightforward. Women, however, frequently experience atypical symptoms, complicating accurate diagnosis and timely treatment. For instance, 1 in 5 women with a heart attack reports no pain at all, severely hindering the likelihood of early intervention. The reasons for these differences remain unclear. Women have a more pronounced and extensive blood supply to the pelvic region and its organs, a feature closely tied to reproductive processes. Unlike men, women are more affected by tight clothing in the pelvic area, which can influence overall health and development. This anatomical difference underscores the need for tailored health recommendations to support cardiovascular and reproductive well-being in women. 5. Body temperature. The hormones estrogen and progesterone, present in higher concentrations in women, play a significant role in regulating body and skin temperature. Estrogen promotes blood vessel dilation in the extremities, allowing more heat to escape into the surrounding air. In contrast, progesterone causes constriction of skin vessels, reducing blood flow to certain areas to prioritize warming the internal organs. This dynamic hormonal balance fluctuates throughout the menstrual cycle, affecting women's thermal sensitivity. As a result, women's hands, feet, and ears tend to remain approximately 3 degrees Celsius cooler than men's, even though their core body temperature is generally higher on average. Core temperature peaks about a week after ovulation, corresponding to a rise in progesterone levels. During this phase, women may feel particularly sensitive to cooler outdoor temperatures, seeking warmth more than usual. Interestingly, while women's extremities are cooler, the higher core temperature may explain why many women prefer warmer environments. This phenomenon isn't exclusive to humans. Studies of birds and mammals reveal similar patterns. Males of these species often gather in cooler, shaded areas, while females and their offspring remain in warmer, sunlit conditions. 6. Metabolism. The metabolic rates of men and women differ significantly, influenced by both muscle mass and hormonal status. In women, estrogens can influence appetite independently of actual energy needs, sometimes driving a specific request for nutrients to support potential future offspring. In contrast, men's appetite operates on a more linear principle, closely tied to their immediate energy requirements. Men also typically have a higher basal metabolic rate due to their greater muscle mass. Meanwhile, women, being biologically adapted for reproduction, have a slower metabolism and a tendency to store fat, which explains why weight gain occurs more easily for them. It is well documented that an imbalance in body composition, particularly insufficient fat, can disrupt a woman's menstrual cycle and increase the risk of pregnancy complications. The genetic basis for these differences is also striking. For instance, studies reveal that up to 1,000 genes in the liver function differently between men and women, affecting various metabolic processes. Women are also more prone to certain digestive disorders, such as irritable bowel syndrome. However, their more sensitive gag reflex often acts as a natural safeguard against many gastrointestinal complications. Men, on the other hand, demonstrate a digestive resilience that continues to baffle scientists. Some have even managed to consume bizarre items, including entire aeroplanes and scrap metal. Given the state of the environment today, perhaps this peculiar talent could be repurposed to tackle the world's plastic waste problem. 7. Bone tissues. Men typically have greater bone density than women, a characteristic largely attributed to higher testosterone levels, which enhance bone tissue strength. Women, by contrast, often experience a marked decline in bone density after menopause due to reduced estrogen levels, increasing the risk of osteoporosis and fractures. Anatomically, women display adaptations tailored to their biological roles. Their thoracic spine is relatively shorter than men's, while the cervical and lumbar regions are longer, enhancing flexibility and mobility. This flexibility is further supported by a more elastic ligamentous system, which plays a crucial role in childbearing. Women's ribcage is typically shorter and proportionally wider, positioning the diaphragm higher while their shoulders are narrower and their pelvis is wider and deeper. These anatomical differences influence physical performance. For example, increased pelvic rotational movement during running results in reduced efficiency compared to men. Additionally, women's skeletons are lighter, more elastic, and mobile, though less robust. Their lower center of gravity improves balance but can limit certain forms of physical exertion. Special caution is advised for young girls regarding activities that increase intra-abdominal pressure, such as lifting heavy weights or jumping from significant heights onto hard surfaces. as these can negatively impact the development of pelvic organs. For those who believe employing women in physically demanding roles like manual labor is a solution to social and economic challenges, consider the stark differences in strength capacity. Historical records suggest Paul Anderson may have lifted an incredible 627.5 kilograms and allegedly supported 2,844 kilograms from racks, though these claims lack thorough verification. Contemporary reliable records demonstrate men's superior physical strength. Hafthor Julius Björnsson holds the world record for a 501 kilograms deadlift, and Mitchell Hooper achieved a 545 kilograms through Hummer tire deadlift, performed with Hummer tires, which alter the lift's starting height compared to standard plates. In contrast, the women's deadlift record set by Tamara Walcott in July 2022 stands at an impressive 290 kilograms. While performance-enhancing substances like steroids are available and often used during training to improve strength, athletes are required to abstain from these substances for a designated period before competitions to comply with regulations. Even with such practices, including matched dosages during training, women's bodies are unable to achieve strength levels comparable to men's due to inherent physiological differences. These disparities underline the biological limits that performance-enhancing substances cannot overcome. Physiological differences can be listed for a very long time, but this would be a rather tedious read, so I will limit myself to just a list where specific gender differences are observed: muscle fibers, fat tissue distribution, skin composition, the epidermis, respiratory systems, endocrine functions, tactility, taste receptors, and differences in the volume, structure, and functionality of brain neurons. For example, the visual cortex shows notable variations in size, influencing focus, peripheral vision, and color sensitivity. Women, for instance, exhibit heightened activity in two types of color receptors, red and green, while one of these types is typically less active in men, whose evolutionary role did not require them to distinguish ripe, stale, or poisonous foods by color for feeding offspring. Similarly, while women do not necessarily have a greater number of olfactory receptors, they have more neurons specialized in processing olfactory signals. This is particularly evident during pregnancy when their sense of smell can surpass that of men by several magnitudes. Hearing differences are subtler. While neither sex has a clear overall advantage, they display sensitivity to different frequency ranges. Men are more attuned to lower frequencies, perhaps to detect distant threats, while women are more sensitive to higher frequencies, such as a child's cry. This may also be influenced by differences in the auricular structure. Women generally have more rounded, less angular auricles, while men often have larger, wider ear canals, even with similar head sizes. Women's heightened sensory sensitivity extends beyond their sense organs to their nervous systems, which are finely attuned to social interaction. Numerous studies suggest that women excel in reading emotions and analyzing their underlying causes. They also tend to experience conflicts or remarks more intensely, whether in professional or familial settings. This heightened sensitivity likely has evolutionary origins rooted in their reliance on social dynamics and the cooperation of those responsible for protecting them during the prolonged period of raising offspring. This heightened sensitivity to emotional cues not only implies greater emotional awareness, but also higher stress levels, which in turn necessitate longer recovery periods. On average, a middle-aged woman requires at least 8 hours of sleep for full recovery, whereas a man can typically manage with 7.5 hours or less. And then there's melatonin, the so-called sleep hormone. Surely one might think this would be immune to gender differences, but not quite. Women reach their peak melatonin production earlier than men, which may explain why wives are dozing off in front of the TV while their husbands are just settling into the start of a late-night movie marathon. Adding to this is an intriguing observation from tomographic studies of sleep. These studies have revealed that the onset of sleep triggers a decrease in functional brain activity, driven by neurons that lower blood pressure. Cerebrospinal fluid flows into the brain to maintain balance and prevent brain decompression. Interestingly, the studies also observed that brain activity decreases more significantly in men than in women during sleep. This difference may once again be attributed to evolutionary factors. For women, the need to care for offspring likely required a heightened state of vigilance, making overly deep sleep less practical. It is worth noting, however, that falling asleep in laboratory conditions can be challenging, potentially influencing the study's results. Or perhaps the women in the study were simply too busy wondering how their brains appeared on the monitors. Summarizing all the physiological data, including numerous unmentioned details, I realized, despite the gentlemanly constraints of my era, a growing sense of responsibility to care for my wife. I came to understand that women require a far larger volume of positive emotions than men, which can be fostered by creating an atmosphere that reduces stress. To this end, we should consider legally establishing significantly longer and more frequent holiday schedules for women compared to men. At the very least, we could reignite campaigns encouraging the simple act of giving up seats to women on public transport. But alas, in moments of societal discontent, fueled by nervous tension, depression, or bitterness, the loudest voices, amplified by the cultural megaphone, proclaim that women need nothing from men. Phrases like gentlemanliness is merely disguised arrogance and a tool for humiliating women have gained traction. The irony lies in the fact that the dominant male majority, striving to be gentlemanly, eagerly embraced this narrative and began eradicating gentlemanly behaviors in themselves and others. And thus the circle closes itself in perfect symmetry. Ephemeral differences in the brain. When delving into gender differences in the brain, it is crucial to acknowledge that the matter is far more intricate than general physiology, given the brain's remarkable plasticity and its capacity to both inherit and acquire specific traits. Despite this malleability, nature operates by its own unwavering principles, ensuring species survival by solidifying traits that enhance reproductive success. If new physiological characteristics fail to improve reproductive efficiency, they are unlikely to become established as sexual characteristics of the species, whether in general physiology or in the brain. The nuances of sexual behavior naturally imply corresponding differences in the nervous system. However, the scope and significance of these differences, whether confined solely to the neocortex or involving a broader chain of brain regions responsible for reproduction and social behaviors, remain a contentious topic. What was once primarily a scientific debate has now been entangled in political discourse. On one hand, recognizing these differences is crucial for advancing research and improving fields such as women's medicine. Ignoring them risks stalling scientific progress, increasing stress and workloads, and introducing a range of social and economic challenges. On the other hand, acknowledging these distinctions risks perpetuating biases in employment, interpersonal relationships, and societal expectations. Legislation can regulate these issues to mitigate their impact, and indeed, it has. However, many reasonably argue that such measures will remain ineffective as long as the perception of physiological differences between the sexes persists in the collective human consciousness. In this context, while numerous independent studies have consistently observed differences in brain structure between males and females, the focus has shifted. Researchers are now less concerned with distinctly male or female morphologies and instead concentrate on the unique combinations of gender-related characteristics present in each individual. A landmark study in this field was conducted by Daphna Joel and her team at Tel Aviv University. Using MRI, they analyzed the brains of approximately 1,400 individuals at a resolution of 250/300 microns, roughly 1/4 millimeter. While this resolution is sufficient to observe structural features visible to the naked eye, it is far less precise than examining an open brain with a simple magnifying glass, let alone a microscope, which was employed by earlier researchers. The researchers reached the following conclusion: the simultaneous presence of anatomical differences in 10 brain regions, areas commonly identified by pathologists worldwide and up to 100 regions noted by some neurobiologists, was observed in only 5–8% of participants. The remaining participants exhibited a combination of male and female traits. The study did not disclose the exact percentage distribution or the specific configuration of these traits across different subjects, aside from noting that 100% matches were rare exceptions. From these findings emerges a new postulate. The human brain is a mosaic comprising features associated with both sexes, as well as a spectrum of intermediate traits. This concept is partially well established, observable to psychologists, and recognized by neurobiologists as gene expression can lead to non-standard combinations and deviations from genetic programming. These external markers also allow researchers to identify suitable experimental subjects for specific data collection. Indeed, each brain is as unique and unrepeatable in its variations as individual faces are in their features. Yet, it is widely acknowledged that a person's sex can be determined with approximately 75% accuracy based on facial features. This is because, while faces vary significantly due to ethnic traits, environmental factors, and individual differences, the underlying skull exhibits relatively consistent sexual dimorphisms. These differences, observed across countless generations of our ancestors, are particularly notable in the following characteristics. Greater angularity and muscle attachment. Male skulls exhibit more pronounced angular outlines and greater development of tuberosities and roughness, particularly at the attachment points of the neck, occipital, temporal, and masticatory muscles. In contrast, female skulls have smoother and more even bone surfaces, likely due to less pronounced tuberosity and roughness. This smoother appearance may also correlate with the different distribution of facial fat tissues between sexes. Lower jaw size and weight. Men typically have larger and heavier lower jaws with more pronounced tuberosity at the angles and along the lower edge of the inner surface of the chin. The average weight of a male lower jaw is 85 grams compared to 63 grams in females. Male jaws often feature more vertical ascending branches, while female jaws have a more horizontal orientation. Additionally, the angles of the lower jaw in men tend to turn outward, a feature less commonly observed in women. Forehead and crown shape. Male foreheads often slope backwards toward the occiput, transitioning into a rounded crown, which may feature a ridge along the sagittal suture. Female foreheads, by contrast, are more vertical and transition into a flatter crown shape. Facial to cranial proportion. In men, the facial region of the skull is generally more developed in relation to the cranial portion, appearing longer and wider than in women. Eye socket structure. Male eye sockets are typically lower, rectangular, and have thickened, blunt upper edges. Female eye sockets are higher, rounder, or oval and have thinner, sharper upper edges. These differences also relate to anatomical variations in the eyes and surrounding tissues. Mastoid processes. Male skulls feature more prominent mastoid processes, often with pointed apices. Female skulls, on the other hand, exhibit blunt mastoid process apices. Nasolabial angle and frontonasal point. The nasolabial angle in men is more pronounced, and the frontonasal point is typically deepened. Female skulls exhibit smoother transitions between the frontal bone and nasal bones, with the frontonasal point often less pronounced. Alveolar process. Female skulls more frequently show upper alveolar prognathism, where the alveolar process of the upper jaw protrudes forward. External protuberances and arches. Men tend to have a significantly more pronounced external occipital protuberance, as well as prominent brow ridges and glabellar arches. If we were to apply hypotheses of phenotypic adaptations for all brain-related differences, one might speculate that these ridges developed exclusively in response to the invention of the Viking axe. Exceptions to these features are exceedingly rare, and even when they occur, they do not indicate a disruption of the genotypic program. Rather, they reflect the individual hormonal balance shaped during fetal development and adolescent maturation, contributing to each person's unique physiological and anatomical traits. Additionally, it is important to consider that facial features can be significantly altered through surgical interventions affecting skin, muscles, fat, bone tissues, and cartilage. A similar phenomenon is observed with the gendered structures of the brain. While the brain's structure and characteristics are unique to each individual, certain universal differences persist with remarkable consistency. Here are some of the most pronounced examples. 1. In the male brain, one hemisphere is typically more dominant than the other, often the left, depending on the lateralization of functions. In contrast, the female brain tends to exhibit more balanced functionality between the right and left hemispheres. 2. Women generally have more verbal centers in the brain, located in both hemispheres, and often of greater volume. This anatomical difference contributes to their superior recovery of speech abilities after a stroke compared to men. 3. The inferior parietal lobe linked to mathematical calculations is usually larger in men from birth. However, in women, this area can increase in activity and connectivity density over time, while the male counterpart may remain underutilized. 4. Neurochemical communication, including neuron connectivity, neurotransmitter secretion, and volume, shows subtle but crucial differences between sexes. These differences influence the effects and permissible dosages of pharmacological drugs. For instance, antisocial personality disorder is more frequently diagnosed in men, while borderline personality disorder is more common in women due to variations in neurochemical processes. 5. Women have richer blood circulation in certain regions of the brain, which may contribute to differences in cognitive and emotional processing. 6. Structures of the limbic system, responsible for emotional processing, memory, and sensory signal recognition, also differ between sexes, even at the cellular level. For instance, women tend to have a larger hippocampus, which is essential for forming long-term memories. The hypothalamus, which regulates appetite, sexual desire, and the sleep-wake cycle, also shows consistent sexual differences in specific nuclei. 7. The amygdala, associated with threat detection and stress response, is, on average, larger in men, potentially contributing to differences in how threats are processed and acted upon. 8. The premammillary nucleus in the male brain is generally larger, which may correlate with more pronounced territorial behaviors and ambition compared to women. 9. The insular lobe, insula. Although not a part of the limbic system, the insula is intricately linked to it and plays a role in emotion processing, pain perception, homeostasis regulation, and interpersonal behavior. The insula and limbic system work together to manage emotional reactions. Studies indicate that women typically have a larger volume of gray matter in the anterior insula and exhibit higher activity levels when processing emotional stimuli. Furthermore, the female brain demonstrates stronger functional connections between the insula and other brain areas involved in emotional processing. Women also tend to show greater activation of the insula in response to pain stimuli, and this heightened activity may correlate with their pronounced empathy. 10. Interhemispheric and intrahemispheric connections. Men tend to have stronger connections within individual brain hemispheres, while women display stronger interhemispheric connections via the corpus callosum. Additionally, the female brain uses white matter approximately 10 times more frequently than the male brain. White matter facilitates network interaction, enabling brain centers to connect with gray matter. This structural difference allows women to switch tasks more seamlessly and process multiple sensory signals simultaneously. Conversely, the male brain relies more heavily on gray matter, about 7 times more than the female brain. Gray matter specializes in processing specific actions and information in a focused manner, which explains why men often find multitasking more challenging. In 2013, researchers from the University of Pennsylvania hypothesized and confirmed through a study that women often outperform men in tasks requiring multitasking. Their findings revealed that the female brain engages a greater number of neural networks for simultaneous task processing. This increased engagement may explain women's greater need for rest and longer sleep durations. 11. Genetic and neurochemical differences. Men and women exhibit differences in gene expression related to the development and functioning of the nervous system, including the activity of neurons, synapses, and neurotransmitters. Sensitivity to neurotransmitters like serotonin, dopamine, and gamma-aminobutyric acid, GABA, varies between the sexes, influencing nervous system activity and potentially accounting for differences in behavior and mental health. Epigenetic factors such as DNA methylation and chromatin modifications further contribute to these distinctions. These mechanisms are strongly influenced by sex hormones, underscoring the inevitability of such differences in shaping the nervous systems of men and women. 12. Brain volume. A common belief holds that the male brain is heavier simply because men, on average, are larger. However, scientific evidence challenges this assumption. Comparative studies and routine measurements by pathologists across various countries reveal a more nuanced reality. Even when comparing individuals of the same height, The male brain typically weighs at least 30 grams more. On average, the male brain is 11–13% heavier and 10% larger in volume than the female brain, irrespective of overall body proportions. It is noteworthy that these comparisons did not factor in overall body mass, as men generally have denser bones and larger internal organs, such as lungs and the heart, even when they share the same build as women. Similar findings have been observed in experiments on primates, chimpanzees, orangutans, and gorillas, where female brains are consistently smaller than their male counterparts. However, brain size does not directly correlate with cognitive abilities. Adult brain mass typically ranges from 1,100 to 1,400 grams, with some exceptions where individuals exceed 2,000 grams. Interestingly, such disproportionate brain sizes are sometimes associated with congenital mental deviations. Research suggests that brain mass alone is not a reliable indicator of intellectual or cognitive superiority. Instead, factors such as brain structure, neural connectivity, and the efficiency of information processing play far more significant roles. That said, studies have identified a correlation in which approximately 75% of geniuses and highly talented individuals had above-average brain mass, exceeding 1,400 grams, including notable women. This finding shows that brain size may correlate with ability but is not a measure of intelligence. 13. Variability and stability. The male brain exhibits greater variability in the volume of different brain regions and cortex sizes, while the female brain is more consistent in these parameters. Women benefit from a more robust biological system due to the duplicate X chromosome showing greater stability in IQ scores than men. They are also less prone to conditions like mental retardation and other cognitive deviations. Moreover, the female brain matures earlier and ages more slowly than the male brain, highlighting distinct differences in neurological development. 14. Frontal lobe differences. Gender differences are evident in the frontal lobes, particularly in the volume of associative zones. These small but crucial regions, comprising roughly 10% of the frontal lobe area, are vital for inhibitory functions and solving complex non-biological problems such as planning, decision-making, and abstract thinking. The male brain often gains weight from larger associative areas in the frontal lobes and the inferior parietal region. However, this increased volume does not always translate to heightened activity. While these regions are larger in men, they exhibit comparable levels of activity in the female brain. This disparity likely represents reserve potential, developed over time as men historically engaged less with offspring, exhibited less caution, ventured into unfamiliar environments, and faced the constant need to navigate and adapt. This relentless pursuit of better living conditions, or their artificial creation, may have equipped men with additional capacity for spatial analysis and environmental problem-solving. The common satirical comparison to the whale brain, where larger volume does not equate to intellectual superiority over humans, misses the point, as it fails to consider species-specific adaptations. If humans lived underwater, faced no natural predators, and required minimal environmental interaction, our brains might also trade excess neural connections for fatty layers. Interestingly, modern men, unlike women, whose biological roles have remained more constant, are increasingly finding themselves in these whale-like conditions, lounging on the couch, ordering delivered pizza, and dodging dangers or challenges entirely. For some, the greatest threats are no longer predators or famine, but lagging Wi-Fi and the terrifying prospect of running out of snacks. Let's consider the most intriguing differences in the next part of this chapter.